Alright, an addition problem, just like with subtraction, if you see an addition problem, you need a common denominator. So we need to see what we have here. I'm going to go ahead and factor these below, and then we'll see what they have in common. So here I have 8 with my first trinomial, 8x squared plus 6x plus 1. 8 times 1 is 8. Two numbers that multiply to 8 and add to 6 are 4 and 2. So I'm going to leave my 8x squared out here, plus 4x plus 2x plus 1. Cut it in half. 8x squared and 4x have 4x in common. And I'm left with 2x plus 1. I have 2x plus 1 already on the other, in my second here, half here, so then I know I just need a 1 out front. So fully factor, that is 4x plus 1 times 2x plus 1. So when I'm looking at this guy and rewriting it, this is the same as 2x minus 3 over 4x plus 1 times 2x. And we're going to be adding that to our other fractions. We need to deal with that denominator next. I think we factored this guy already. 2 times negative 1 is negative 2. Two numbers that multiply to negative 2 and add to negative 1 are negative 2x and 1x. I really think we did that earlier on this page. The first two terms have 2x in common. The next two terms have 1 in common. And my parentheses match, so I'm feeling good. So that's my second denominator there. 3 on top. 2x plus 1. So I'm going to ignore my original problem, and now I'm going to look at my guys here, see what they have in common and what they need. If I factor too fast for you, pause and back up. That's the great thing about a video. You don't have to go my speed. You can go faster, you can go slower, you can pause where you need to, rewatch, fast forward, whatever speed you need to go. All right, when I'm looking at my two fractions here, they have 2x plus 1 in common. So my first fraction needs the x minus 1. And what I do to the top, I have to do the bottom. What I do to the bottom, I have to do to the top. My second fraction has the 2x plus 1 and needs the 4x plus 1. Sometimes I feel like it's a little bit like playing same and different. Okay, now each of my both of my fractions have all three components to the denominator they need. They have x minus 1, they have 4x plus 1, and they have 2x plus 1. So that's my big new denominator. And now what I need to do is combine like terms, multiply first, combine like terms, and see if I can factor anything in the numerator. Alright, x times 2x. Make sure that you are treating that like it's in parentheses. We are going to double distribute here. X times 2x is 2x squared. X times negative 3 is negative 3x. Negative 1 times 2x is negative 2x. Negative 1 times negative 3 is positive 3. And in my second fraction, I have a plus in the middle here, so we don't have to worry about distributing any negatives like I do when I'm doing subtraction. So that's lovely. I am going to distribute my 3. 3 times 4x times 12x. And 3 times 1 is 2. So that is one mess of a numerator that we need to take and combine like be very careful with each algebra step. A lot of what we practice in this class is precision for algebra, so you have to be precise in order to do upper level math. 2x squared doesn't have any like terms. I have negative 3x, and I'm going to cross it off once I use it, so I don't did not use it. Negative 3x minus 2x is negative 5x, and then I have the positive 12x, so 12x minus 5x is 7x. And so I use all those guys. And then 3 and 3. And all 29. Just like our last problem, we need to see if this was factored. So I'm going to do 2 times 6 is 12. I'm looking for two numbers that multiply to 12. That was my numbers that multiply to 12 and add to 7. Does factor. So we're going to do a little extra step here. 2x squared. Hopefully we'll be able to make something. Plus 7x plus 6. I'm going to change my 7x to 3x plus 4x. Bring down my 2x squared. Bring down my 6. My first two terms have an x in common. My next two terms, 4 and 6, have 2 in common. When I factor out it's 2, I'm left with 2x plus 3. It's lovely. X plus 2. Good. Alright, that's right. What we've got. So I'm going to replace my numerator with x plus 2 times 2x plus 3. And nothing cancels, which is really disappointing. Even though I've done this problem multiple times, that's disappointing to me that I did that factoring work and nothing canceled there. But that's our final answer. It's still lovely. Factor form is really important. When we do rational functions later this quarter, you will learn how important factored form is. What factored form of a rational function does is it gives you your x-intercepts for the numerator and in the numerator. So here, our x plus 2 and our 2x would give us x-intercepts, which is really important information. And then our denominator gives us where our x. But that's for a later. That's the only problem with this video. So if you need to see that crazy problem with the p's and q's, you're going to have to click on that.